So we don't have to do clickers today. You have an announcement. It's Sharma. All right, there we go. I'm working. Sharma has something very special, I think, for someone very special.
Is there a Julie Ha in this class? I have a message for you.
Whoa! Happy Valentine's Day! Do we know who it's really from? We love love! I went to get Elmore's coffee thing at 3 o'clock last Friday.
Figure out what that
was about.
Done that?
And it was all about love. And people was like you would stand up and what love meant to them. And some were talking about their parents and their relatives and then the crush. Falling in and falling out. Okay, falling out. Your midterms are ready to come back to you. You will get them in lab, or you can go contact your TA and get to their office hours and pick them up. The average grade was 76.6, which is actually right on the mark. I've been teaching this kind of class, this class forever, and that's about normal. All right? But the histogram, which I couldn't figure out how to produce, was very asymmetrical. There was a whole big trail that went out into the low C's, D's, and F's. All right? And I'm here, I told you, I don't teach a class. I teach a student. All right? A lot of you did wonderfully. A whole lot of you did wonderful. But there was a whole bunch of you that just sucked. And we have to figure out why. If you're one of those, as you will learn, and you come every day to lecture, come talk to me. Maybe it's Texas twang that's throwing you off. It's going too fast. I can help you. All right? Come see me. If, on the other hand, you're one of those, and I have about 15% who pretty regularly don't come. Okay, I know who they are. And if you find, yeah, that's me, well, guess what? It's not working, and you're going to go down. And we want you to do well. I just want to take a moment. A whole bunch of people did really well. The lowest grade was 37. The highest grade was 97. Okay? Here is the star group. Evan Altman, Jacqueline Babbitt, Diana Balakou, Katrina Baku, Nicole Delana. I'm not having you stand up. Elizabeth King, the highest grade. Aaron Lane McCoy, Adam Levitsky, Caleb Matag, holy cow, Robert Petrovic, Emma Ruse, Lauren Taylor, Mary Lazali. Yeah. What? So, pretty good, huh? That's the star group. And you know what? They're not any smarter than you. They just figured it out. All right? They're here. I know all of them. They're here. And they started working on this midterm early. Okay? But you have 2 midterms. You have a final exam. You've got a field trip or term paper. You got a PowerPoint to factor in and a lab story. So this one exam is only about 18% or something like that. Not too bad. All right, stay with me. Yes, ma'am.
So if your name wasn't called, you just get an A? Is that what
Yeah.
you're Okay.
Now, I'm commonly asked, do I curve? No. I haven't had to curve grades in years. I used to. But I will. If the average grade, when we're all done, if the average grade is less than 80, right now it's 76, okay? The average grade is less than 80, then I take that difference and mark it up to 80, okay? And that's sort of classic. But right now I don't, get with me. The fact is that a whole bunch of you made A's means a lot more of you can. So let's get on board and do this. Let's do it together, all right? Meanwhile, if you're the ones that are struggling, it'd be a huge mistake not to come in and talk to me. And let's find out why. You should get that exam back, go over it. Now here's my gift. Of all the gifts, here's my gift to you. The midterm, the final exam rather, is cumulative. About half of it will come from midterms 1 and 2. And listen to this one word, verbatim. Okay? It'd be really dumb to miss the same question twice. Okay? So we're giving you your exam back. We're giving you the answer keys. All right? Now that midterm comes your study guide. You can just throw away all your notes for midterm 1. It's just those 3 pages. All right? And start learning that stuff down. Okay, is that a gift or what? Okay, we'll do the same for the second midterm. All right? Are you good? All right. And you're here. And I'm delighted. All right. Whoa! So, woo-hoo! So today, we're going to rivers and floods, and not a better topic for good old Boston. This place was built on water. A whole lot of Boston was all water everywhere, and they, bit by bit, they filled it in. Scoot by. I've got a great book for you, written by an environmental engineer for Boston to help dig out the polluted waters. Her name is Alice Outwater, and she was an environmental engineer for Boston. The Big Dig, it's called, or something. It's a grand book. Every chapter is about nature and water. For example, beavers are amazing. All right, they like to cut down trees and slow down the movement of water from getting into the ocean, from where it's no longer useful. They slow down that water so it can sink into the ground, help feeding our groundwater. All right? So she has a whole chapter just about beavers and how we damn near killed them all off. First, all across Europe, into Russia. The fur trade is huge. All right? And then into the United States, we almost eliminated this animal. All right? So it's really, really cool. Another whole chapter on buffalo. Because buffalo like to get out and wallow around, making a depression in the prairies that captures water. So the ducks and geese coming by have a place to rest, roost, and reproduce. So it's the Alice Outwater, and it's called water, a natural resource. She now lives on a farm in Vermont, raising a family and writing books. Not bad. Environmental engineer, Alice Outwater, water, and natural history. Okay? So water, we depend on it, all right? It's all part of a natural cycle. We call it the hydrologic cycle. Most of our ocean, most of our water is in the oceans, 97%, 97.3. 97.3% of every raindrop is from the oceans. Or everywhere else. And it evaporates, it's part of the cycle, and then it comes back down, precipitating as rain or snow, and then it fills our lakes and our streams, and then a whole lot of it sinks underground. That's our most abundant supply of fresh water, is underground water. We call it groundwater. All right? But surface and streams, those are our surface streams. That's our most powerful agent of erosion. We look at the shape of the land. So this wonderful cycle, a balance of nature until we come along and change all that. You want a job. All right, and I've had several words for you to go through 4 years of college and come back out. You know, what am I going to do? Well, do something with water. The demands, because we're now hitting the 7 billion mark in this world. The demands for knowing something about water. Alice Outwater, never going to go away. Okay? So here we go. It is a balance of nature. It is ultimately the source of sand for our beaches. Today we're finding our beaches are disappearing. Disappearing. Barrier islands and beach sands going away all over the world. Why? Because we've cut off the source. We've built a dam. All right? I told you, echoing Bill Nye, you can't pick a flower without touching a star. Who thought if we built a dam to make electricity and hold back water for farming and recreation because you can go water skiing, you were going to cause the barrier islands all over the world to go away? Exactly what's happening. All right? It's the source of fresh water. Whose phone? Is that your mom? Oh, God. Hello? Hello? Well, this is a classroom in what's Stone Building B50. But I have like 160 people looking at me. Somebody's been evidently calling from that phone and charging it to him. Okay, you want to know what that phone was? Wow. And floods. Another aspect about rivers is that they flood. Oh yeah, you knew that. No, super floods. Not the annual floods, but every 10 years, big ones. Every 50 years, bigger. Every 100 years, amazing. Sometimes 300-year floods. So we didn't understand this when we settled our land. When the early settlers came into America, they loved to get near rivers. From Boston to Pittsburgh to New Orleans, they planted on rivers. Well, rivers have what we call floodplains, where they're supposed to spread out and let it flood, bringing new sediment to make the soil nutritious. It's supposed to flood. We built our homes there, our schools, all right? And we like rivers for transport, for water, to dump our sewage, transport. So look at that. So here's some of the big issues. Super floods, there it is, 100-year cycle. And then when you have a break in a levee, there are two kinds of levee, a natural levee that I'm going to show you, but then the ones we build alongside the river to keep the water from getting into the floodplain. We've done that. We have armored rivers all over the world, so they no longer can get out into their floodplain. And yet, when you get a big flood, at some point it's going to break. What's unnatural here is that I've got 1,000 miles of river that's breaking in one spot, when it should have been able to spread itself out over that 1,000 miles. Now that 1,000 miles of water is coming out in one spot. We have created the super flood, okay, because of our construction. And there's a bit about the barrier islands that are disappearing all over the world. Here's where our water is. I've told you ocean water is 97.3%. All right, so you're evaporating and you're precipitating. You're evaporating, you're precipitating. When you're precipitating, that's the erosion side. That's the erosion side. We're going to talk a lot about erosion today. And that water comes down. But most of fresh water, 2.7%, is as ice. Now it's melting, but it's ice. Can't exactly drink that, although there have been proposals to go tow an iceberg to Saudi Arabia. All right? And then it gets down just to a little bit in our lakes, in our groundwater, and very tiny in our rivers and in our atmosphere. But that's our water. To understand our rivers, we need to be able to see their differences where they are. High up in the mountains. Whoa, hello, Holly. High up in the mountains, there's where they start. Rivers are very different. They don't have floodplains. They still flood, but they're mostly eroding there, eroding, shaping the land. We call that a youthful stream. I'm going to show you. Way down, when you go down the river's elevation, they have this concave downward slope to what we call the base, which is where it meets the ocean or meets a lake. All right? And down here, rivers have a huge floodplain. Their channel only occupies part of the floodplain. All right? And they're meandering back and forth. They'll be all over that floodplain at some time. They're meandering back and forth all over that. All right? The big changes as you go downstream is that the width of the river gets bigger, the depth of the river gets bigger. And this will be surprising to you, because you think about rivers high up in the mountains, look like they're really moving fast. Well, they're churning and falling over rocks and whatnot. But they actually go a lot slower than rivers way down here. You go down and hop into a river closer down. It's actually a very dangerous river, big turbidity currents moving in it. All right? And so all three of these factors, width, depth, velocity, all increase. We multiply those together in what we call discharge. Discharge is how much water is moving at one time. The total volume with its velocity, okay? Cross-sectional area and its velocity. That's how much water is there. It all increases as you go down. All right? And as the streams move, as you move, a stream is not going to run straight very long. When you go snow skiing, do you go straight down the hill? No, you're going to go out of control. So you start curving. Start curving. That's exactly what the stream does. It's controlling its destiny, all right? And so it starts turning. We call those meanders. It starts meandering, and it erodes on the outside of the bend. And on the inside of the bend, it actually deposits. All right? It deposits. So if you're water skiing, do you ski on the inside, on the outside or the inside? What would you do? Inside? Well, I'll tell you what, I've done that. And you're going down and you're skiing along, here I go! And you suddenly, and your skis have got those runners underneath, and suddenly you feel like you're dragging bottom. Holy cow, don't fall down, because everything's going to be gone. All right, now, see on the outside, that's where the water is deeper. The water's deeper out here, okay? Water deeper on the outside. That's where erosion is. And so, if you were to build a home on a river, would I do this? Yeah, I might. Just knowing it might not last forever, but I might, because I love fishing. And I can sit out on that porch and drink a beer and watch the sunset and have a fishing pole over the balcony. All right? But would I put that house here or here? It's eroding on the outside. It's eroding. So this meander, this river is soon going to be out here and out here. So which is going to last the longest? You want to be on the inside. All right? Back away a little bit. All right? Because the floods are going to get you. Be up on stilts. But you won't be here. You're going to be eroded away. You see that? It's got a cliff. And now let's go. So there's a real river. It's eroding on the outside, cutting into, steepening the mountain. Steepening. We just learned about landslides. Steepening the mountain. Right? Rocks are coming down. It's eroding out here. And on this side, it's depositing. All right? Look at all the cobbles. Does it ever flood there? Does that river ever lift up and even get higher? Well, look at these water cobbles. Look at that. What? Examples. In rock this week, in the lab this week, you're learning about rocks and minerals. One rock is called andesite. You know about andesite. Comes out of subduction volcanoes. There's an andesite. Not black like basalt. There's andesite, all right? And it's angular. It just fell out of a mountainside. No, actually, I went up to a mountainside with a rock hammer and knocked it out. Well, that's what they look like when they fall out. They're angular. But they fall into a stream, and round and around they go, and they turn into cobbles. Bigger boulders, smaller pebbles, all the way down to sand sides. And they get rounded. They get rounded. So when I pick up andesite cobbles like this, and I think I've showed these to you before, right? And I don't even see an andesite. I see this water that did this. A stream, and it might also be a beach, but it's got to be water that's taking these cobbles and moving it down and making them round, round, round. So you walk up, and there they are. Does it ever flood here? Well, yeah. Are those moving right now? No. How did they get there? The last flood. All right? The last floods. Are you with me? Am I saving your life one more time? So the outside of the turn, cutting, making it steeper, feeding into last week's lecture on landslides, steep, the rocks are falling down, angle of repose. You got it, angle of repose. There we are. And here we are on the inside of the turn. Look at that lovely point bar. Wouldn't you like to take your shoes off and run out there and have that sand, that water-saturated sand come up between your toes? Oh, it's just lovely. There it is. So, does it ever flood there? Oh yeah, look at that point bar. It was deposited there in the last flood. So from sand to boulders, you see the evidence. There we go. As part of the hydrologic cycle, as the water comes down, it's eroding the land. Plate tectonics causes the land to go up. Here we're looking at the Colorado Plateau, lifting up and going up even as we speak. And the rivers are eroding it. Look at them. Moving, digging, digging, eroding, eroding. So the rivers are now stretching up further and further in places where they've never been. Just like you. You are youthful. I am old age. You are youthful, eroding, eroding. They've been here before. Yahoo! Cutting into the mountainside, all right? And as they cut, no floodplains, they have steep walled valleys, making them steeper, and then the landslides on both sides, we'll call those sides that fail. And then the debris falls down into the river and it carries it away, and the cycle continues, eroding and then landsliding and eroding and landsliding, cutting and making V-shaped valleys, headward erosion, We call these all youthful streams. So that part of the hydrologic cycle is creating the topography, running water of the four agents of erosion: wind, gravity, ice, water. It's the most powerful. Okay? Most powerful. So you walk out into a stream, and it's got sediment. Come with me. Take your shoes off. Pull up those legs, and let's wander out. You got a fishing rod. Here we got a stream that has cobbles and pebbles on its bottom. Are they moving right now? No. Does this stream ever flood? Oh yeah. You see, they're there. They're there. And when those cobbles come down, as you'll learn in lab, they make a rock, a sedimentary rock called a conglomerate. All right? So when you look at that, oh, wow, like the Putting Stone conglomerate, state rock of Massachusetts, created, some think, by the great melting of the snowball earth. Wow, there it is. A lot of Boston homes and churches and libraries are built out of the Putting Stone conglomerate. That's what it looks like, just like that. So, youthful streams, high up on the profile, waterfalls and rapids. Look at it, it looks like it's coming fast, but it's actually very turbulent, very high energy, mostly eroding. Yeah, those boulders aren't moving right now, but how did they get there? And they're already starting to get rounded. Let's take a look at the fun we can have in flooded water. Okay, look out! Woo! Woo! All right, I'm with you. Do this with me? Hey, 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 hey! Oh, suck. They got a life vest on. Hey! They're coming out of there, right? There he is. Hang in there. Where's the other one? Oh my God. Oh. Here we go. This is in Idaho. Little shaky, but it works. Come on. Heart's racing. Are you going to do it? You got a seatbelt? Don't get a seatbelt. Where's he going? He knows I got him. Woohoo! Okay, here we go. Don't put a seatbelt on. Why? You should be upside down. Let's see what they do. Here we go. Hang on there. Hang on. River rafting. Save the beer. Oh. Oh, Lord of mercy. So, high up on the profile, it's mostly about erosion. Steep walls. Make it steeper. Landslides will bring it down, and then the water takes it away. Gradually, as the erosion continues, it's all V-shaped. The river valleys get wider. But look at that. We're just starting to get a little bit of a floodplain in here, not much. So as the rivers win. But it takes years. The Appalachian Mountains, created by the double continental collision that it was formed, huge interior mountain belt that it once was, now re-rifted, is eroding. And it's been eroding for 300 years. It's now a mere relic of the great mountain range that it used to be, mostly rolling hills. All right? And in parts used to go all the way down into Texas and into Mexico. That's all gone. Okay? But so the rivers win. As the land goes up, that triggers the hydrologic cycle. The higher they up, the further they fall. So as you begin to wear down the mountains, the V-shape gets broader. You start getting a floodplain, more of a floodplain. So would you put a home right there? Oh, no. Not a mosquito suit. Look at all that. That's really wet stuff. But good for fly fishing. Now, I've got a real floodplain, just a small one, right there. There it is. Floodplain. Plain that it floods. And before we come along and put levees there, now this has no artificial levee. It actually has a natural levee right along the edges. And that's where the trees are. Trees are there because the farmer can't use that very edge. When the river floods, it spills out and drops its load, its sediment, and the coarser debris, the cobbles and pebbles, sand, all drop right at the edge, and then the muddy water spills out and deposits nutritious soil. All right? But the coarser debris right on the edge, it can't be farmed, but it's great for trees. This is called a natural levee. It's higher, it's a little ridge right on the edge, okay? It's always there. All right, let's take a look. Here's another one. Now, I've got, this is a mature stream, no longer youthful, in their 40s. And We call it a mature when the meander belt fills the entire floodplain. So the floodplain goes from here to here. Notice, no homes on the floodplain. Where are the homes? Above it, okay, where the river never goes. So I'm teaching you to recognize a floodplain. That's what it is, a floodplain with sandbars. And look, if I show you a slide identify and say the row of trees on the river's edge is on the A, B, C, D, you choose natural levee. Okay? Natural levee. There it is. There it is. That's the natural levee. Natural, made up by depositing pebbles and cobbles at the edge of the river. And now an old age stream, that's me! the meander belt only occupies part of the floodplain. This floodplain is so huge, I'm not even sure where it stops. Maybe out here somewhere. It's big. And all of it subject to floods. Okay, the 100-year flood. 300. And that meander belt doesn't just stay over here. It's going to change with time. You can see here, it used to be there. Okay? There's part of what now is a small lake. All right? And in fact, it cuts on the inside. It cuts on the inside. So what's going to happen to that neck of land right there? It's going to cut off. All right? It's going to cut off, and this will turn into a lake. Here's where one has already happened. That's called an oxbow lake. Isn't that wild? And eventually it will silt in. Look at that. Wow. Woo, woo, woo. And here's the Mississippi River. All right. Old age, floodplain, so far apart, so across I can't see across it. All right. The whole thing subject to floods. All right. So we've gone from youthful streams where it's V-shaped, no floodplain, out into the mature and the old age, where you have a huge floodplain, and the channel only occupies a part of that. All right? So let's take a look at some more of these old streams. Here we are in Cambodia. And here is the river. It's got a point bar on the inside where it's depositing, eroding on the outside. So these rice fields over here will someday be eaten away. But notice, no homes. The rice paddies are everywhere, but no homes. Okay? Then back away, go through the highlands, come down here, and then use those natural flood waters to flood their rice fields every year so they can grow more crops. Here is an oxbow lake. Here's an oxbow lake. All right? It looks good. So here's how it forms. You erode on the the outside of the turn. You erode on the outside so it gets closer and closer. You cut it off, and there's the oxbow lake. Okay? Good. And there's one forming today in Montana. There it is. What's wrong with this picture? Yeah, you see the homes? Somebody didn't take Earth Science 105. Look at the homes. Look at the homes. Look at the homes. All right? All of this on the floodplain. The edge of the floodplain is about right there. That will be all up in here. Crazy! So the mountains rise because of plate tectonics, and then they start eroding in here. They're eroding, and the water's flowing toward us. The water's flowing toward us, moving the sediment, carving away the mountainside. Look at all the point bars. Does it ever flood there? Yeah. Look at all the point bars that aren't moving right now. Okay? Came there in the last flood. All you got to do is say, how much water can come here? Well, go look for the biggest rounded boulder. And you got to have enough water with enough velocity to lift the biggest boulder, moving all that sediment. There we go. And then the water comes out, finally reaches its base. Often that's the ocean, unless we stop it. Or it might be a lake, all right? And the water stops and makes a delta. Delta is part of this. If we allow rivers to be natural, they go all the way to the oceans, where they deposit sand, where it can then be reworked by ocean currents and taken to our beaches to resupply our beaches. Because we get to shorelines, and you live on a shoreline right here, sand is always moving by rivers and longshore currents. It's always moving. But if you come along, so as the sand goes out, I got to have new sand coming in. But you stop the damn train. Because you stop the sand at a dam, you see. The Charles River is damp. So we can get out there and have great crew races. That's good. But I haven't asked the question yet. I hope they let the water out at the bottom rather than at the top. Because if they don't, if they're just letting the water at the dam flow out over the top, the fish can't get upstream and the sediment can't get out to the beaches. You see what I mean? It's all here. It's all here. So that's what's natural. There we go. The Mississippi Delta formed over multiple stages. Here are 7 different stages. There's the youngest part of the delta, no longer lives because we killed it. Mississippi Delta is dead and sinking into the ocean. And that's why Hurricane Katrina. It's armored with levees, walls along the sides of the river to keep it from spilling out. No more flooding. No more flooding. Mississippi River has levees all the way down on both sides, keeping it tight, and then that water runs right out that channel, out into the ocean. None of it spreading here, and so the delta is simply sinking away. Subject, we know this now, it's below sea level. New Orleans is below sea level because we let it die. You can't pick a flower without touching a star. Amazing. Out in drier parts of the world, when you have water coming down and there's not enough water to take to the ocean, it deposits right at the base of the mountain. It's called an alluvial fan. An alluvial fan. Would you build a home there? Created by superflow. We call them flash floods. All right? Out in the drier areas of the world, rivers come down. Only when, is there water there now? No. No, it came with the last storm. We call it a flash flood. And it erodes like everything else. It erodes like water anywhere else. And it comes out and spills out at the base. Makes a beautiful alluvial fan. Some of the most beautiful features. Look at that. All right? Coalescing alluvial fans we call bajada. Bajada. Anybody know Spanish? What does bajada mean? Huh? Downward sloping? Perfect. Thank you. Downward sloping. They call it. Look at it. Look at it. Look at it. Would you put a home in one of those? Come with me to Lake Havasu, Arizona. All right. Look out. Look at this beautiful view from Google Earth in Mongolia. Look at all these alluvial fans all coalescing. What a wonderful bajada. If I show you that, what's the word? Bajada. All right. You're with me. But we stop this. All right. We build with lots of concrete dams all over the world holding that water back for recreation, for farming. It's making electricity, no better power than hydroelectric. But we didn't realize in picking that flower the consequences. We make beautiful reservoirs. You go out to Lake Havasu and go skiing, all right? You're supposed to ski clockwise. Once I was in here, I had my kids along. We got a houseboat, towed a ski boat behind it. It was a hoot, a lot of beer, and I'm driving along. Here came a ski boat, and the guy was driving butt naked, and he was pulling the girl was driving butt naked, and he was pulling a guy that was butt naked on skis. I went, oh my God, he's going to fall! Almost broke my neck as I tried to follow them going by, and he did fall. God Almighty. Heaven help the Jules. So, we make these wonderful reservoirs. There they are. But the thing is that the sediment is not getting. So the sediment comes in. It's now got an artificial base. Here's the Colorado River coming in, and it hits the Lake Havasu, or Lake Mead, and the sediment is no longer going to travel to the beaches. And you wanted a beach home in North Carolina or in Oregon. And that beach home pretty soon is going to be in the water. Come to me at Galveston, and I'll show you. They're in the water. They're gone. All right? Because here's an example of a small dam built in 1926, and 21 years later, filled in. Look at that. This picture was taken in 1947. This is up above Malibu. The Malibu colony wanted a dam to hold back water to supply the village. And look at that. And then the salmon, who for years had been coming up this river, Malibu Creek, throw themselves at the walls of the dam, trying to do what their ancestors could do. Throw themselves at the base of the dam. Here's the top of it. All that sediment, all filled in. So, impacted dams. We know the pros. They've got clean energy, absolutely clean energy. Water as a drinking resource, also for farming, for recreation. Yahoo, clockwise. But they are a sediment trap. They impact our beaches. The fish can't get up. So we've now touched the star. Okay? All over the world, we're now blowing up dams, taking them down. We try to find other forms of energy. Jobs. Okay? Jobs. Trying to find the right solution, as Alice Outwater did. So here we are on a floodplain, mostly uninhabited. But look at, there's one house. There's another one. Trees on the natural levee, the meanders, oh, you're great. I'm going to cut off right there someday. Used to be here. Beautiful. This is up in Northern California. I'm driving down, having worked up in the state of Washington, out near Leavenworth, and I'm coming down with my dog in my truck, and I slammed on the brakes. I had to go take a picture of that. Look at that. A small street and a floodplain. And on that floodplain are cattle. That's perfect. Floodplains are great for farming. They're great for cattle raising. All right? No homes. Because they will flood out there. And that just helps make the soil more nutritious. We love that. And on the flip side, in the more drier regions, you don't get a delta, you get a alluvial fan. There it is. Water-rounded rocks. Is there any water there now? No. How did those get there? The last flood, we call it flash flood. And man, woman, can they flash? So in areas where you got lots of water, there it is. There's the Mississippi at flood stage. Let me show you a 300-year flood that happened in 1993. This is 1998 after that flood. But this is the Missouri River. Here is the Mississippi River. This is all farmland. A satellite view with color changed, green and red. But look, it's all flood. Both rivers share the same floodplain. It goes all the way across. Who's talking? Boom. The whole thing. The two rivers became one. Look at that. Back up. Wait. No. Oh, no.
The Mississippi River.
No. Back. Man, woman, I haven't made that mistake in a long time. I got one thumb. Who thinking you can run off like that? So, both of them flooded. There it is. 300-year super flood, 1993. Amazing. There's St. Louis spilling out over the levees. All right, here's the Great Arch. All right. And here's the point break. There were hundreds of these levees that broke. But you're getting thousands of miles of water that in the natural world, Sean, would spread out for thousands of miles on that floodplain. But now they're coming out of one place. All right? Super unnatural, eroding away. Holy God, everything's gone. Over 12,000 farms in Illinois alone were flooded. 1993.
The Mississippi River claims an enormous amount of land for its floodplain. In the spring, floods occur again and again along the river. Farmland is rendered useless when the land is drowned and the topsoil is washed away. The river that made the surrounding land so fertile can also be devastatingly destructive.
All right, excuse me, back on. And so, when you think about where water comes from, you have the concept of a drainage basin. And the Mississippi River Drainage Basin, that's all the area. It's our biggest drainage basin in America. All right, the Amazon would be comparable. The drainage basin is the area where all water is dedicated to a single stream through its tributaries. Okay, and so this is the drainage basin of Mississippi. It's huge. It occupies over 1/2 of America. Look at that, and it can have super floods. The industry in the Mississippi River affects all of us, but on a smaller stream. Let me show you a super flood. Here's the Pedernales River outside Austin, Texas. Hook 'em horns. Kids playing on a rock bar. Okay? They got out of there. But look, this is what it can do. All right? The power. Look at that water. Holy gosh. Boom, boom. That's the same place. All right? All right, you're with me. So evidence for flooding, it's all over the place. Debris, rocks moving on. You look for your biggest boulders. You got to have water that's fast enough and deep enough to pick that thing up and hurl it downstream. Can you pick up that rock? No way. Look at that. The Kern River Valley, California. Would you build there? Would you go hiking with me in that canyon if there were dark, thunderous clouds up ahead? You'd go, F you, doctor. I'm going to town. Whoa. So here in Utah, cute little flash flood. Look at that. Right now it's a debris flow. It's the landslide we call a debris flow. It's the front of a flash flood. All that debris. Hey, honey, I think we better get the car out of here. Oh, there's funny looking. I want to get out and look at it. I'm going to get out there and kick at it. I'm going to put my stick in it and move the car, honey, so we can go home. Wait a minute, we're working on this. I think maybe I can't get across now. Damn it, George, I told you we should go. Oh, man, look, your daddy said get home by 3. There's no way. What am I going to do? Call him. There's no signal out here, stupid. Oh, boy. Oh, boy. Maybe we'll walk. Mm-hmm. You walk. There we go. Here's a bigger one. Now we're in Virginia. Flood stage, building. Flood stage. Who's from Virginia? All right, here it is. Building up. We better get across. It kind of got late. Hey, we got to go home. We're not even supposed to be out together. What are we going to do? Turn around and go the other way. Oh my God, our parents are going to find out. What are we doing over here? This is really bad luck. Oh honey. Wow. The Rapidan River, 1995. Look at this. Look at that tree. The power of the water is so big it lifts the entire tree. Crazy. That's pretty cool. Whoa. When did this thing start, dude? 4-lane highway. There's the debris. Floods. So they're real. They're natural. Natural. Till we come along. Oh boy, we got a mess. What a living room this is. Look at all the trees. Man. Crazy. This is another one. In Italy. And here you got a flash flood coming through an auto store. Look at the cars. Come on, get that one out of the way. All right, there we go. Now get that one out of the way. So the water has jumped over the banks into, but they put a car dealership on the floodplain. Why am I always yelling? Crazy. Things you can find on YouTube. Woo! 2010, so last September. Pretty wild. Hey, I saw this Dr. A's class. Boy. So, we try to control our floods. We have catch basins. We have dams. This is cool. What's that? Can you see it? This is a catch basin in California, Altadena, California. Look at that. Look at that. Pretty cool. And it's there to catch the debris at the bottoms of our mountains. All right, so we try to control floods. The idea of having super floods is now completely understood. We're now just also beginning to predict when it will happen. What is the probability of a 100-year flood in 100 years? What would you say? 1%. What is the probability of having a 50-year flood? Yeah, 2%. Okay? So you get it? 10-year floods? All right, you get the idea. So we got this recurrence interval, all right, and it really happened. 50-year flood, 2%. Remember those numbers, okay? Write them down. All right, they'll come back to you. I'm promising. So the mountains go up, they erode, running water, spreading out alluvial fans, heading for us. So to protect areas built below alluvial fans in drier areas of the world, we build these huge catch basins, and then we dig them out for the rest of the year. So flood recognition, floodplains, we can recognize the topography. We look for recent debris and sandbars and gravel bars, and then just dig a hole. Dig a hole. And go down and find layers of cobbles and data and find out how often do you do this. All right? Pretty wild. So here we are looking out across Monument Valley. Look at all that grand land. And I'm saying water, water, water. Water erosion. Working steeping the land, letting the land slide down, and water eroding all the way. All right, all carved by running water and mass wasting. Beautiful landscape. What made it? Running water. Even when running water's not there, it'll be there later. Next big storms are coming in. Maybe to wait for an El Nino year. We've looked at running water high up on the profile and seen waterfalls and rapids with rafts going over them, and that looked pretty cool. Now I want to take you lower down the profile. Here's a geology student looking out over Death Valley, where in just a few weeks I'm taking a whole bunch of Boston University undergraduates out, and we're going to go out for 8 days of camping out in the Death Valley and the Mojave Desert. Death Valley, wonderful, beautiful place, created by running water. There it is. Now, I take you to low down on the profile. Cal State Chico students on the American River, things you can find on YouTube. Look at all these youthful people. Low down on the profile, there's no rapids, no waterfalls, and just a whole lot of tubing. Rick, did you bring the beer? What was wrong with him? There's the floodplain, American River, away from the mountains. No rapids and waterfalls, plenty of water, all right? Because down in the profile, it's wider, it's deeper, and it's faster. But it's all right, look at that. She needs to have more clothes on. Crazy. Those cops. Who's screaming? Wow. All right, let's go do this. Rafting party. I think this is an annual spring. And funny hats. They don't have hats like that in Boston. Oh dear, move on. What are they doing? Somebody is laughing. Having a wonderful time. Low down on the profile. What does this mean? I've never known. Hey, police, out of the way. Oh dear, what's she doing? Get those tubes out, and with that, I bid you farewell. Have a wonderful day.